Following are good practices generally followed for PCBs. These are to be used by studying circuit types and application. Noise is an undesired random disturbance of a useful signal. Ground and supply noise. In electronic circuits, controlling ground and supply noise is an important task. This is most serious problem with TTL ICs, less severe in case of ECL ICs and much lesser in CMOS ICs. Following are measures to tackle this problem using PCB layout. Broad supply and ground tracks should be placed on opposite sides of PCB. Cover all unused parts of PCB by ground. For multilayer boards, one layer should be designed for ground. Add decoupling capacitors. Decoupling capacitors are preferably ceramic, but never electrolytic or any wound type. As mentioned in lesson 4, strictly avoid using same ground line for analog and digital circuits. CMOS ICs are less susceptible to noise, but they can be easily destroyed by overvoltage. This calls for special protection circuits, especially against electrostatic overvoltages. It is advised to add external protection circuits, even if internal protection is added. In high frequency and high pulse applications, keep power supply and ground lines short and broad. Use large ground surface. Provide decoupling capacitors. In analog circuits, use small circuit paths. For small signal circuits, avoid ground loops. Separate ground lines for digital, analog and reference circuits. In power electronics circuits, divide circuit into high and low power paths physically on PCB, preferably on separate PCBs. Select appropriate base material with good thermal properties. Select appropriate base material thickness to mount heavy components. Select appropriate copper foil thickness for larger currents. Proper selection of terminals and tabs for wire. Checklist for films. Are PCB dimensions mentioned? Is PCB identification visible and legible? Is all lettering and numbering correct and legible? Is spacing between pads and tracks proper? A well-designed PCB, proper films and good manufacturing practices result in a good PCB. Employing good PCB assembly practices are as important as making a PCB. PCB assembly is mounting components and soldering them. A correctly assembled PCB has a significant role in making a product reliable. This concludes the course on PCBs. In this course on PCBs, we looked into interactions between different departments and material and information flow among them. We studied good practices in PCB design. This course is aimed to make one aware about various aspects of PCBs